Good day. Today we will tell about the structural types of crystals. Look at the screen, please, the first classification, and then we will look through the structure of copper, magnesium, tungsten, and rock salt as the most spread. Structure types of crystals is a regular spatial arrangement of atoms, ions, sometimes molecules, that make up crystalline substances. A crystal with a certain chemical formula has an inherent crystal structure that has a three-dimensional periodicity crystal lattice. The structure of a crystal is the specific arrangement of particles in space. In most inorganic compounds, interpenetration of infinite packing of cations and anions takes place. The geometric description of a particular crystal structure consists in indicating the coordinates of the centers of atoms in the unit cell of the crystal. This makes it possible to determine interatomic distances and study the geometric phases of the crystal structure. The task of classification is one of the main tasks of the crystal chemistry at the present stage. At present, more than 1,000 structure types have already been identified, but they cover only a few percent of the known crystal structures. In the international classification by groups of structures, the following classification is adopted. A. Elements. B. Type IB compounds, for example, sodium chloride, cesium iode. C. Compounds of type AB2, such as these substances. D. ANBA type compounds, as aluminium 2 oxygen 3. E. Compounds formed by more than two kinds of atoms without radicals or complex ions, for example, copper, ferrum, serum. F. Structures of compounds with diatomic or triatomic ions, as here. G. Compounds with tetraatomic ions. H. Compounds with pentaatomic ions. L. Alloys, and S. Silicates. Varieties of types within a group are distinguished by numbers. For example, B1, D1, F2, and etc. Here you can see the structure of copper. The concept of structural type is one of the criteria for the similarity or difference in the structure of crystals. Usually, the structure type refers on the name of one of the substances that crystallize in it. The structures of crystals belonging to the same structural type are identical to the point of similarity. Structural type in a crystallography determines the relative arrangement of particles, atoms, or atomic groups in a crystal without specifying the absolute distances between them. To describe a particular structure, you must specify the structure type and structure parameters. The most important and common structure types include structure copper, type A, structure tungsten, type A2, structure magnesium, type A3, structure diamond, type H2, structure graphite, type A9, structure rock salt, type B-iodine, and etc. Now we look look the structure of copper. In the structure, as an example, in the structure type of copper, many metals crystallize. For example, gold, silver, nickel, aluminium, calcium, thorium, lead, etc. All these metals are relatively soft, ductile, and easy to process. Many of them form continuous role-solid solutions. For example, argentum, aurum, copper, and aurum. The intermetallic augments, aurum stibium, aurum to bismuth, and etc. These substances also have a copper-type structure. The elementary cell of copper is cubic face-centered. The atoms are located at the vertices and centers of the F cell faces. There are 4 atoms per unit cell, and each atom is surrounded by 12 nearest atoms, so coordination number is 12. The coordination polyhedron is Cuba Octahedron. The structure has one regular system of points with multiplied 4, and the densest layers are perpendicular to the directions. The densest cubic free layer packing is ABC, ABC, etc., and space group FM3, 3M. Next structure of magnesium. In this structural type of magnesium, hexagonal metals crystallize as cadmium, beryllium, thallium, titanium, nickel, chromium, and etc. This structure is also characteristic of intermetallic compounds such as argentum cadmium, copper cadmium, and etc. The elementary cell of magnesium is elementary primitive. The centers of atoms are located at the vertices of regular hexagons. At 3 vertices through 1, the atoms of the upper layer, and 3 other vertices, the atoms of the lower layer. The unit cell is built on 3 translations, 2 of which lie in a densely packed layer of atoms and make an angle 120 degrees between themselves. The third one is perpendicular to this line. The unit cell can be divided by a plane into 2 trigonal prisms. An atom is located in the center of one of the prisms, the other is free. Populated and empty prisms alternate with each other. There are 2 magnesium atoms per unit cell. Each magnesium atom is surrounded by 12 nearest atoms, 6 in the same layer, 3 in the next layer above, and 3 in the next layer below. So coordination number is 12. The dense layers are the planes of the bases 0, 0, 0, 1. The packing is hexagonal. 2 layers as AB, AB, AB. Metals crystal with a densely packed hexagonal structure are most easily deformed along the 0, 0, 1 planes and directions corresponding to the densest packing of atoms. The coordination polyhedron is a hexagonal Cuba octahedron, and the space group of magnesium is P6, 3 derived MMC.